All right, so what we're doing right now is we are going to go quickly review over law of sines, and that'll take us to the law of cosines today. So when do we use law of sines? And the trick was this. If I said you have any triangle, and if I give you an angle side pair, meaning I told you this is going to be, let's say, 32 degrees, we'll call this 10, and I'm going to give you one more angle. I'll call this angle over here 45, okay? So if you have an angle side pair, meaning you have one angle and its opposite side, you can use law of sines, okay? Use law of sines. Let's label the sides A, B, C, with little b being across from B, little c being across from C, and little a, 10, being across from 32. Just for us to have some easy naming convention. So law of sine says this ratio is always true. The side over the angle is equal to the side over the angle. Okay? And you can do any of the mix between A, B, or C, as long as you set up with this same proportion. A over sine A, B over sine B, C over sine C, the ratios will always be the same. So the way I had you guys do this was first figure out, do you have an angle side pair? Yes, we do. We have all our A's. So we have a full set. Next thing you have to do is pick something you want to solve for, just like what we did before. And in this case, you have to pick something that you have almost a full set for. So looking at C, angle C, I have the angle, but I don't have the side. So the way we set this up is I first write what we don't know on top. I don't know side C. I don't know side C. But I know angle C. So it's almost like you're trying to get a girl's number. You know her first name, but you don't know her last name. At least you know something about her. You can say this about boys too, okay? So we write sine of C, but we already know what C is, angle C. And we're going to say angle C is 45 degrees. This is equal to the same type of fraction, side over angle. The side that we know is 10, and the angle that we know is sine of 32. Okay? So now, looking at this problem, I only have one variable. So to solve it, I just need to move sine to both sides. So the opposite of division is multiplication. So I write sine of 45 to both sides. That divides out. And the rest is calculator work. Now you have to make sure you got to work with your calculator and figure out how to type this stuff in your calculator. On my cheap Apple calculator, this isn't even one that came with Apple because they don't come with calculators. Oh, we're going to get an ad. Sorry. So I'm going to type this 10 times sine. Oh, my calculator is cheap, so I don't type sine. I type 45 first. Sine. And then I hit equals. That's the top part. Okay, that's just the top. Then we follow by divide by 32 sine. And then we have to mix it by then hitting equals. That's my cheap calculator. If you have a nice calculator, you type it as you see it. Okay? A $15 calculator these days will even write it as a fraction for you. Okay, so on the calculator, I'm going to clear it. I'm going to make sure my calculator is in degree. If you look in the upper left-hand corner, it says degree. So 10 times 45 sine, and you're going to see sine is going to change the 45 right away. Bam, 45 became 0.70 equals, to mix the top, my top of the fraction is 7.0. And we're going to divide that by 32 sine equals, and I'm given the side C is equal to 13.34. I'm going to round to C is approximately 13.3. Now, that's right now. See if this makes sense. If I write 13.3 for my side C, remember, that's a round off answer. Without me doing any work right now, would that be a kind of good answer? I want you guys to compare this. if I told you that 32 gave me a side of 10, it opened up to be a side of 10. Well, wouldn't 45 have to be a bigger side because 45 is a bigger angle? So yeah, 13.3 is bigger than 10 because angle 45 is bigger than 32. So at least it looks like an answer that would make sense. 33.3, perfect, good job. Now, I want you guys to look at this triangle. Do I know anything for B, side B or angle B? As we look at it, no. But we could find out what the angle is, because what do all angles add up to in a triangle? They add up to 180. So you can do 180 minus 45 minus 32 on your calculator quickly. This will give you something like this is 77. So we're looking at 103. If you beat me, awesome. Okay, so I know this angle is going to be 103. Now, just to talk about it, if I know this angle here is 103, what do you think about this side? Do you think it's going to be bigger than 10, bigger than 13, smaller than all of them? Remember, a big angle means a huge side. So we're going to look for our biggest angle here. And just like before, we're going to set up law of sines in the same exact way. We're going to write what I don't know equal to everything I know. So I'm going to write B over sine of 130, well 103, I'm sorry, is equal to, and remember, we stick with the same type of fraction, side over angle. Now you could use 13.3 and 45, but that's going to give you a round off error, and you don't want that round off error if you don't have to. Some problems you have to, that's just the best you got. But right now we still have the 10 and the 32. So I'm going to write 10 over sine of 32. And the problem becomes just like the last one. B is equal to 10 sine of 103 over sine of 32. Okay, awesome. Now, 18.4, cool. 18.4, if that's the answer, that is excellent. That was fast too, good job. 10 times 103 sine equals, divided by 32 sine equals 18.38, rounding up to 18.4. Great job. And if you're like practicing this and you're getting faster, even better, because on the SAT, you're only given like 2 minutes per problem, maybe 3. So the less time you spend on each of these easier problems, you can spend more on the harder problems. Okay, get rid of this for now. Okay, so today's lesson is going to kind of go off a little bit off this. And we're going to do something called Law of Cosines. Make sure you're taking notes. Law of Cosines. Now, when do we use Law of Cosines? Pretty much the answer is when Law of Sine doesn't work. Law of Cosines works when Law of Sine doesn't work. So I'm going to draw you a couple of pictures in which we can't use Law of Sines. So here is my first one. It's a side, side, side triangle. If you see an SSS triangle, meaning I give you 3 sides of a triangle, you cannot use law of sines. Why? Let's take a look. Here's my example. 3, let's not do 3. Let's do 4, 5, and 6. 4, 5, 6. This isn't a special 30, 60, 90 triangle. That was 3, 4, 5. 4, 5, 6 is not a special triangle. If you try it, to check if this is a right triangle, 4 squared plus 5 squared is not equal to 6 squared. Pythagorean theorem doesn't work, not a right triangle. So for our rule we just said, to use the law of sines, you need what? What can you automatically recognize that this is a law of sine triangle? You needed a angle side pair. You need to be able to fill out one of the fractions. If you can't fill out one side, you do not have enough information. So, do we have any angle side pairs? Let's look at A, B, and C. Little a, little c, and little b. Okay? Looking at A, do we have an angle side pair for A? I know side A, but do I know angle A? Nope. B and B, I know side B, but I do not know angle B. Nope, can't use law of sines yet. Look at C, I know side C, but I do not know angle C. We do not have one complete set. We cannot use law of sines. The law of sines is easy compared to law of cosines. So no angle side pair. Here's another one in which we cannot use law of sines. The triangle looks like this. We'll say it's going to be 40, and we'll say this is 5 and 6. I do not know, call this A, B, and C. This is a SAS triangle, side angle side. Great question. Can I use trig ratios? And answer is no, because you need to have a right triangle. Just as a reminder, for let's say sine is equal to opposite over hypotenuse, you can only have a hypotenuse if you have a right triangle. And none of these triangles are right. That's right, good catch. So none of these triangles are right. So I'm missing, let's see, do we have an angle side pair? Little a, no pair here. B, nope, missing my angle. And C, I'm missing my angle for C. So there's no way for me to use law of sines. And if you guys did the IXL yesterday, you found out, you know what? It's not that hard. It's actually pretty easy, pretty quick. Okay, so we have two types of law of cosine equations. Now I'm gonna go ahead and show you guys the website real quick. I included a nice picture of it. I actually went to a website and copied all these different parts of it. I copied and pasted everything. Now we have two versions of it. We have our standard form. You can see up on the right here. A squared equals to B squared plus C squared minus 2BC cosine A. A little bit more confusing, but it's actually going to be really easy to remember, and I will walk it out with you. The second version is cosine of C, or even cosine of A. Let's look at the second one. Cosine A is equal to B squared plus C squared minus A squared over, you know what? Looks a little confusing. But I'll walk it out with you, and you'll see it's actually exactly the same equation as this one on the right. But I want to tell you guys, what's the significance between the two, and which one do you choose when you're solving this? Which one do you choose? Well, if you look here, the top one, it says solves for sides. So if you're solving for sides, you're going to use the A squared one, because A squared is a side. We're solving for a side, A squared. The alternate form, if you look here, it's cosine of an angle. We're going to solve for an angle. Okay, so that's good. Let's spend the rest of our time today working on these two different versions and working on our calculators on how to type these in. So make sure you do have a calculator nearby. Okay, let's talk about our first version here. So solving for sides. So this is going to be for SAS triangles. Let me say this. You wouldn't use this for an SSS triangle. Why? Because when I say solving for sides, we already have all three sides. We don't need to find another side. We have all three sides already. So for SAS, this is our rule. A squared is equal to, okay, automatically what would you say? If you say A squared, next thing you're probably going to say is B squared plus C squared. And now here's where it changes. It's going to be minus 2BC cosine of capital A. I want you to see this relationship. If I'm solving for side A, cosine will always be the angle of that side I'm solving for. Let me say this again. If I'm working on A, it'll be cosine of A. Let me draw this out more practically. I draw you a triangle, and we call this little a, I'm solving for little a. I don't know what it is. Well, I better know angle A. And we mentioned before, that's called at 40. And we also need to know the two sides. This is A, call this B, call this C. Little b and little c are the two sides that we better know already. And in our example, I think we called it 5 and 6. Okay, so let's reiterate what type of triangle this is. This is a side, angle, side triangle. Side, angle, side triangle. For side, angle, side triangles, we don't know the opposite side, so we can't do law of sines. So our goal is to solve for this side first. That's actually the only part we can solve for. And that's an angle. Nope, that's a side, right? So here's what we do. We fill out everything we know. A squared is equal to your sides that are adjacent to you, which are 6 squared plus 5 squared minus 2, because didn't you have two sides? Two sides, what were those two sides? Well, it's B and C. It's 6 and 5. Cosine of the angle we're looking for, which is 40. Cosine of the side. Okay. Now, again, let me do this one more time. Let's try it. A squared is equal to, we don't know A, but we can use the other two sides. So we know B and we know C. Minus 2 of the sides you just wrote. You just wrote 6 and 5. So that's right, 6 and 5 again. Oops. 6 and 5 again. And don't forget, this is law of cosine. So we write cosine of the angle that we were looking for. Sorry, angle of the side we're looking for. Okay. Now, here's what I'm going to say. All this work on the right is all calculator work. On the test, if you show work, this is the work you need to show. If you do not write this, I think you're using a calculator someplace, and I cannot give you credit. Let me say this again. If you do not show this line right here, you will not get credit for the problem on the test. If you have any questions, you can ask me about that, but you will not get any credit. So from here, we actually plug into calculator. A squared is equal to, let's go ahead and find our calculator again. And we're going to type 6 squared plus 5 squared equals, can't wait, mix those up just together, that's 61. I'm going to write it here just in case I mess up along the way, because the next part is actually going to be pretty tough. We're going to hit minus. Now, look at the parentheses. I'm going to stick this all in one big parentheses. So let's be careful there. It's going to be parentheses, open parentheses, 2 times 6 times 5 times 40 cosine. I'm going to close my parentheses and then hit equals. You end up with the answer, oops, minus all this. This is 12 times 6 is 60 cosine of 40. Okay? So you guys can copy that if you want. 2 times 6 is 12. 12 times 5 is 60. And then we end up with 15.03. Now you are not done. You are not done. Because we did not solve for A. Everyone, I want you guys to please pay attention here. We did not solve for A. We solved for A squared. Because if I write 15 here right now, let me go ahead and zoom in for you guys. If I write 15 right now, 15, you've just committed triangle suicide. This side here cannot be 15. Because we have a triangle sum rule where the two sides of a triangle are always bigger than the third side. I'm not sure if you guys remember that rule. This is not 15. if I give you a triangle, let's call this 15 here, and I give you the left leg and the right leg. If the right leg is, sorry, the left leg is 5 and the right leg is 6, we have to find the square root. This can't even form a triangle. The arms are too short. This is his fat head, his big belly, and his arms are too short. He can't even like pin them together to form a triangle. So we need one more step here, and Nasber said it. We need to take the square root. So a is equal to the square root of 15.03. Now the cool thing is that on your calculator, your number is still there. We're just going to take the square root, and we end up with a is approximately 3.88. We're going to round that up to approximately 3.9. Now, what 3.9 makes sense here? If I wrote 3.9 instead of that dumb 15 answer, which ripped apart my arms, 3.9. Is 40 degrees that big of an angle? No. So the side, compared to the other ones, not that bad. So from here, we can solve for the other angles if you want. But what I'm going to do now is do this next move, and I'm going to solve using Law of Sine now. Now, once we solved, take a look here, please. Once we solved for the side, don't we now have an angle side pair? And if you have an angle side pair, you can now use Law of Sine to solve the rest of these angles. Let's go ahead and rewrite this triangle down here. The triangle was it 40, 40, 6, 5, and we said 3.9. We have an angle side pair now. That's solved using Law of Sines. We couldn't use Law of Sines before, but if you guys did the IXL, wasn't Law of Sines pretty darn easy eventually, once you did it enough times? So here's what we're gonna do. Can someone shout out, do you guys wanna solve for B first or C first?
B.
B, okay. C, I'm gonna tell you the easiest one to solve for. Solve for the smallest side, okay? If you have a choice between 5 and 6, solve for the smallest side. And if you do that, you will never get the answer wrong. If you solve for the biggest side, you actually stand a chance in getting it wrong. So here is a big deal now. Now, solve for not the biggest, but for the smallest. Solve for the smallest side now. Right, once we find out one angle, we can then find the other angle solving to 180, right? But right now, I don't have enough information to solve for the other two angles. I only have one angle. That's use Law of Sine now. So we said the smallest side was 5, so let's solve for sine of c over 5 is equal to, now we have a set for sure, sine of 40 over 3.9. Okay? We're going to multiply 5 to both sides. Sine of c is equal to 5 sine of 40 over 3.9. How did I do that? I multiplied 5 to both sides. And this is all calculator work now. Let's go ahead and do the calculator. Oops, sorry. Did it again. Okay, I'm going to type this into my calculator. We're going to type, unclear, 5 times, remember, in my cube calculator, I always have to type the angle first. 40 sine equals, divided by 3.9 equals. Now, does 0.82 look like an angle to you? Does 0.82 look like an angle to you? No, that's not even 1. So we have to do one more step. We're going to sine inverse our C. So we're going to hit sine inverse. My button is here. Your calculator probably has to just shift. We end up with the angle 55.5, rounding up. 55.5 degrees, rounding up. Let's go to C. C is 55.5. And if we have two angles, we can then, for sure, combine them to find the third. 55.5 plus 40, that's going to give me 95.5. That means angle B must be 84.5 degrees, because 180 minus 95.5 gives me my 84.5 degrees. So we have solved for all three sides and angles, 84.5. And if you want to double check, remember how I said small angle, small side, large angle, large side? Small angle, smallest side, then largest angle, largest side. Sure, we can do one for the new IXL homework, but let's see. What number did I inverse? Okay, I inverse this number here. I did 5 times 40 sine equals, divide that by 3.9 equals. Then I undid that sign. That's how I got the 55. You don't want to solve for the largest side. And the reason why is because the angle sine will never give you an angle when you inverse it over 90 degrees. And when you do that, let me go ahead and give you an example here. Just on the side. So sine inverse, okay, can't go over 90 degrees. It's not in the range of the calculator to do it. So if you have an angle over 90 degrees, it's going to actually give you the wrong answer. And that's one of the things we talked about, the problem with law of sines. If it goes ASS triangle, don't make an ASS out of that triangle. It will give you the wrong triangle. So for this hint, always solve for the smallest angle, because for sure that will be right. Now, if you don't want to, let's try using law of cosines for all this. Now, I'm going to go ahead and first give you guys an example of law of cosines when we work backwards to solve for the angle. So now this is the process that you guys have to do on your test. You will get one or two of these that you have to work out the whole triangle. And with practice, you can do these in less than 4 minutes. If you don't practice, you can spend a half an hour and you're still not going to get it right, or you'll mess up on small steps. So let's go back and look at our triangle, and we're going to use the alternate form for law of cosines. Actually, do you guys want me to do another problem like this? Really quick? Okay, let's do one more quick problem like this. SAS, okay, SAS means side, angle, side. So give me a triangle. Call this, I'll call 62 degrees here. Call it A, little a, and we'll call the other sides B and C. This will be 4 and 6. Okay. So do I have any angle side pairs? Nope, I don't know what that is. So we can't use law of sine. So instead we have to use law of cosines. How do I know to use A? Because this is the only angle I know. That's the only angle I know. So we're going to set it up, and it's going to be A squared equals to the other two sides. Other two sides. So A squared equals to B squared plus C squared minus, what do we say? Minus dos, minus 2 of the angles that we just wrote, B and C, 2BC. Then cosine of A, because it's always matching the side we're dealing with. Okay, let me say this again. It's always, if I'm looking for A, we say equals BC. Come on, it's the other sides that we better know. Minus 2 of the angles, 2 of the sides we just wrote, BC, cosine of A. So for this triangle, it's going to be A squared is equal to BC, 6 squared plus 4 squared minus 2, 6 times 4 cosine of 62 degrees. All this stuff here is calculator work. So why don't you guys practice right now, typing this in the calculator. 6 squared plus 4 squared minus, write the parentheses, is that right? Yeah, 6 squared, that's right, minus, sorry, plus 4 squared minus parentheses 2 times 6 times 4 times 62 cosine, close it, equals. Now 29 is not my side for sure. We take the square root of that. We end up at A is equal to 5.42. This is how much work I need to see on your test. If I don't see it, I can't give you credit. You can use your calculator, but you cannot give me an answer without the work. A is 5.42. Not only did we solve for the side, we now have an angle side pair, folks. Ladies and gents, we have an angle side pair. That's please run back to law of sine. If you want, you guys can keep doing law of cosines, but we have to learn our next rule, and we'll learn that in just a little bit. Following up my last logic, do I solve for the biggest angle here, or do I solve for my smallest angle? Do we solve for the big side or the small side? What did I tell you as a hint for using law of sines? Do I solve for the big or the small? What did I say? Solve for the small. Solve for the small one. Brian, if you solve for the big one, the angle might be larger than 90 degrees and sine will crap you out. And it'll give you the wrong answer. So you have to solve for the small one to guarantee we're going to get the right answer. Okay? So we're going to solve for the small one. Oh, you're just kidding? You're kidding, but people are like, oh, Brian knows what he's talking about. Okay, so I'm going to solve for the smallest. So I need to solve for C then. Sine of C is an angle over 4 is equal to angle 64. So sine of 62, 5.42. All this stuff is calculator work. Sine of C is equal to 4 sine 62 over 5. You know what? I'm going to write 5.4. 5.4 rounding to my nearest tenth. And then that's all calculator work. 4 times 62 sine equals divided by 5.4 equals. Now 0.65 is not an angle. We're going to undo that by sine inverse. C is approximately 40.8 degrees. Wait, no, that's an angle. Yes, that's an angle. Oh. Okay. Now I unfortunately am running out of time here, so I'm gonna do the last version of this. So we're gonna solve for angles. Angles, solve for angles. And this formula goes cosine of A is equal to, all right, get ready. So if I am looking at A, it goes backwards. It goes B squared plus C squared minus the A squared over 2BC. Let me say this again. If I'm looking at angle A, you better have the other two sides. So this is what the triangle looks like. If this is A, B, C, okay? And we mentioned before on our last problem, let's call this 4, 5, and 6. If I want to solve for angle A, this guy will be my negative version, right? See, that's my negative. Everyone else is positive. So it's cosine of A is equal to B and C. Here's my B, here's my C. The order actually does not matter. 6 squared plus 4 squared minus 5 squared all over 2 6 times 4. Okay, bye. Now, all this stuff is calculator work. So please follow along as I type it in the calculator. You can type it as you see it. If you want, you can put a parentheses to be safe, but I'm just going to use an equal sign on top. So it's going to be 6 squared plus 4 squared minus 5 squared equals going to mix it, give me 27 on top. If you want, you can write 27. On the bottom, 6 times 4 is 24 times 2 is 48. You can write that if you want. You don't need to. Divided by, I'm going to do a parentheses, 2 times 6 times 4, close parentheses. See, that gave me the 48 I wanted on my calculator. Equals. And then, so we have cosine of A is equal to 5625. Then we're going to undo the cosine. How do we undo this cosine? Cosine inverse. A is approximately 55 point rounding up 8 degrees. 55.8 degrees. 55.8 degrees. Now that we solve for an angle side pair, okay, you can use law of cosines now. No, sorry, law of sines to solve for the rest if you think that's easier. If you wanted to, you could just do law of cosines for the whole triangle. Do it 3 times, and that would work also. If you want, you can practice that. If you want to solve for cosine of C, let's do cosine C. Okay, cosine C, cosine C. So if I'm doing cosine C, that set it up. Let's use the letters. I'm solving for cosine C. This is equal to B squared plus, so let's go the other way. Let's do A squared. A squared plus B squared minus C squared over 2AB. Take a look, the pattern is actually super obvious. We always minus the angle we're looking at. And we always 2AB the sides that are adjacent to us. So to fill this out, cosine of C is equal to the others. So 4 is my opposite, so it's 6 squared. Well, let's do 5 squared plus 6 squared minus 4 squared all over 2 times 5 times 6. On your calculator, you can do this in 10 seconds if you practice enough. 5 squared plus 6 squared minus 4 squared equals, divided by open parentheses, 2 times 5 times 6, close. See, I'm not even at 10 seconds. I'm like at 6 seconds. Then we're going to shift cosine this. So cosine C is equal to 0.75. I'm going to undo this cosine. End up with C is equal to 41.4. It looks like, not the quadratic, it looks like the Pythagorean theorem. And there is a reason why that's true. It looks like the Pythagorean theorem. Okay. But we don't have time to go into it today. Okay, so we could do this 3 times if you want. You can say cosine of B now is equal to, let's see, if this is B, right? That's B. So it's going to be 4 squared plus 5 squared minus 6 squared all over 2, 4 times 5. And you can do this, again, like 3 different times. Calculator for the win. Yeah, maybe, because it's just really set it up and then calculate the rest. But for the work on the test, you must show me the setup. If you don't show me the setup, I can't give you any credit. None. Okay, if you do that, you're going to get the same answer. Now, I'm going to redo a problem. I'm going to say this is 55.8, 5, 4, and 6. Okay, I'm going to, instead of doing law of cosines, what if you want to give the credit? No, you got to show the work. Okay, all right. So for this problem here, ready for this problem here, you're going to, I'm going to solve for C also. C, A, B, I think. Yep. I'm going to solve for angle C, but I'm going to use law of sines. And actually, it'll be faster. Remember, using law of sines, solve for the smallest angle first. If I have to choose between 4 or 6, 4 is smaller. Let's do C. That guarantees I'm not going to get a wrong answer. So here we go. Sine of C over 4 is equal to, look, we have a pair now. We have a pair. Sine of 55.8 over 5. Let's see if we get the same answer. Sine of C is equal to 4 sine of 55.8 over 5. So it'll be 4 times sine. Oh, remember that doesn't work. On my calculator, I always have to type the angle first. 4 times 55.8 sine equals, divide that by 5 equals. So we end up with sine of C is equal to 0.6616. Keep on going. And I just need to hit the inverse on my calculator. And we got 40 sine, C is equal to 41.4. Same answer. Okay, so today's work on IXL, you're gonna try these problems 2 different ways. If you start off with a SAS triangle, okay, that means we have to solve for the other sides. We're gonna solve for the opposite side of the angle that they gave you. If they give you angle A, like in this example here, you have to solve for side A. So that's why we start off with A squared equals to the other 2, B and C. If they don't give you any angle at all and they give you all 3 sides, you have to use this alternate form. Cosine is equal to B squared plus C squared minus A squared over 2BC.